Okay, so one of the things I will say is that sometimes rather than actually getting the equation, maybe you just know some information about it. Somebody has described a shape to you, and we've kind of done that in other circumstances before. So what we're going to do is try to look at what happens if someone has just told you particular pieces of data about an ellipse, and we wanted to come up with the equation. So I just kind of scripted out a couple of questions that should work for this. Now, what I have right now is vertices at -1, 7, and 17, 7. So when I look at that, -1, 7 is just some random point, and 17, 7 is some random point to the right of it. Well, if these are my two vertices, then the center has to be right smack dab in the middle of those two. So all I have to do to find the center is literally add and divide by 2. 7 plus 7 divided by 2 is 7. -1 plus 17 is 16, divided by 2 is 8. So I already know that in this particular ellipse, my center is at 8 and 7. And we always like them to be equal to 1. So I'm already getting there. I know this distance from here to here. If that's 8 and that's 17, from here to here is 9. It's going 9 units in both directions. And remember, that's A. But in the value of the story, we always write A squared in the whichever direction it's opening. Now, the last thing is it says the ends of the minor axis are at 8, 10. That's up here. So it looks to me like 8, 10 up here went up 3, and 8, 4 is down 3. So since we went up 3 and down 3, that makes B the number 3, and that's going to make a number 9. And I now have the equation of the ellipse with those characteristics. Now, sometimes we can be a little bit trickier. This is a problem that's a little bit trickier. I gave you some kind of an ellipse like this, where I gave you a center, a focus, and a vertex. Now, keep in mind, I do know that this is an ellipse. So if there's a center and a foci, there's another foci above it and another vertex above it. But we have plenty of information here to do that. C is the distance from the center to the focus, and from here to here is 7 units. Now, I know that you're going to say it's down, but it's just how far, and that's an absolute value. I also know that the distance from here to here is 9, and that's going to be A. And I was a little bit concerned about that because A is actually always tied to the big axis, and since these things are lined up vertically, the big axis is going to be the Y. So let's go ahead and do that. I'm going to go ahead and take my center, x minus 4 squared, y minus 5 squared. And because A is 9, I actually just totally made up this problem at random. I didn't mean these both to have the number 81. But the last part of this is a little bit interesting, that somehow I have to figure out what that is. But if I took root 81 minus b squared, the big one minus the little one, I'm supposed to get the number 7, because that's just kind of how that works. You take this one minus this one and square root it, and you're going to get that value of c. So I personally would go ahead and just square both sides so I wouldn't have to deal with that. And it doesn't take much to see that b squared would be 81 minus 49, and I got the number 32. And so we could replace this b squared that's sitting here with the number 32, and I now have that problem as well. So again, we don't have to have all of the data, we just have to have enough to figure out what A, B, and C are. Now, the next one is a little bit trickier. I have something about the eccentricity. Now, again, I gave vertices and eccentricity. Now, I gave you a little formula before that is C over A. And the thing that's a little tricky about it is when you say E is C over A, that doesn't literally mean C is 1 and A is 3. It just means this may be that right fraction 1/3, or it might be 2 over 6 or 10 over 30, or something that's equivalent, because we always express fractions in reduced form. So I just know that somehow if I take this ratio, I'm going to get 1/3. So let's see what happens. So I've got 11, -5, somewhere over here, and it looks like I've got -7, -5 over here. So I've got some kind of ellipse going this way. And again, you don't have to sketch it. It just helps me. And so what I know is that the center of this thing is right in the middle. Those two things add up to 4. And if I cut that in half, I get 2. And so from here to here is 9, and from here to here is also 9. I somehow got the number 81 everywhere on this one. I just made up random problems. So I know that my ellipse has this set of characteristics. What I do not yet know is what that b squared is. So literally those vertices give me everything except for b squared. But there's a couple of things that I know. I know that the eccentricity is 1/3. So let me see how I want to do this exactly the right way. So somehow, if I take these two things and I subtract them and take the square root, that's going to give me c. Okay, that's c. And a, of course, is this value right here, 9, that somehow that ratio has to be 1/3. Now, there's a variety of ways that you could do this, but I'm just going to go ahead and cross multiply real quick. And that's going to allow me to square both sides, just like I did on that last one. And sometimes you can just look at these problems and see them relatively quickly. But in this case, I had to do a little bit more math, and I figured out that that magic number that would make that happen is if that b squared right there was exactly 72. And so that's just a way to actually come up with the equation of the ellipse, I keep saying hyperbola, of the ellipse from some given data. Now, the other part of this video that I wanted to consider is what happens when somebody gives me the wrong form, because this is not in the pretty form like all of these other problems that we have done. So we're going to do some pretty serious completion of the square. So I'm going to go through here and quickly group together all of the x's. So there's an x here and here, but notice that I pulled the 4 out of both of them. I grouped the y squareds here, and then y squared and y, and I pulled the 9 out of both of them. Sometimes you get lucky and they have something in common. Sometimes you don't. We'll see what happens. Now we're going to complete the square here. Half of 6 is 3, and 3 squared is 9. Half of 2 is 1, and 1 squared is 1. Here's the big, scary part of the story. Please, please pay attention. I didn't really add 9. I actually added 36. So I have to be fair. Over here, I didn't really add 1. I added 9. So putting it all together, this 4 still sits. This is x minus 3 squared. The 9 is still sitting here. This is y plus 1 squared. And all of this stuff just totals out to 36. We're really, really close. But remember, we like this to be equal to 1. So to do that, we're going to go through and divide every single piece by 36. And now we have a nice, easy form. It's an ellipse centered at +3, -1. It's actually going to open in the x direction because 9 is larger. It's going to go over and back 3 in the x direction, up and down 2 in the y direction. And the c value is going to be the square root of 5 in the x direction. Now, the last one, I did want to have one that's a little bit more obnoxious. So again, if we grouped the x's together, and I'm going to have to play with this a little bit, because if I factor the number 18 out of 12, 12 over 18 is 2/3. So I have 2/3 x right here. 18 times 2/3 is 12. You can check that out. Plus, if I pull the 45 out of this one, 270 divided by 45 is 6. So minus 6y equals -272. Now, these are kind of big, obnoxious numbers, but we're going to go ahead and play our game. Half of 2/3 is 1/3, and 1/3 squared is 1/9. Half of 6 is 3, 3 squared is 9. Now again, that's just like the star that I put right here. 18 times 1/9 is 2. And 9 times 45, let's see what that is. 9 times 45 is 405. So putting it all together, 18, x plus a third. Over here, 45, y minus a third. Let's see, so if I took 405 plus 2 minus 272, I got 135. We're super close. Actually, this is a great version of the ellipse right now, but we're going to do one more thing, and we're going to divide every little piece by 135. And so we got the one that we're hoping for. I believe I designed this to be well right here. So if I wrote this as an upside down fraction, 135 over 45, remember multiplying by a fraction is dividing by its reciprocal. That's just the number 3. And then over here, if we took 135 over 18, that's the fraction 15 halves. So rather than writing it in this way, I could put 15 halves in the bottom, and that would be an ugly ellipse in terms of how it would play out, but that is a valid form in HK that we were hoping for. All right, I will see you back in class to tangle with hyperbolas next. See you back. Bye-bye.